Hi, everybody. This is homework chapter 6, part 2. We will be concluding our chapter 6 problems. We'll be doing problem 61, 73, and 81. Let's begin. Problem 61 reads, a 5-kilogram object in free fall reaches a terminal velocity of 50 meters per second. The drag force is proportional to a speed raised to some power, n. That is F drag equals negative B V to the N, where B is the drag coefficient. If N equals 2.5, determine the value of the drag coefficient. All right. So we are given, F drag equals negative B V to the N. And we know that F drag here is the force of gravity. So when we reach terminal velocity, the force of gravity is going to be equal to the force of the drag. So we are at a constant velocity. So we're going to use mg equals negative b v to the n, and we're solving for b. So mg divided by v to the n equals b. Okay, so we have 5 kilograms, 5 kg times 9.8 meters per second squared. The g is going to be -2, so these that's where it cancels with that. V is 50 meters per second, right? 50 meters per second. 50 meters per second, and then our n was 2.5. So our coefficient of drag is going to be 0.00277. 0.00277. And that is 61. All right, 73 reads, in the game of tetherball, a 1.25 meter rope connects a 0.75 kilogram ball to the top of a vertical pole so that the ball can spin around the pole as shown in figure 536. Find the tension in the rope when the ball completes 0.5 revolutions per second. And the angle of the ball is 35 with respect with the vertical. Okay, so what do we have here? We have something like this. This is 35. That's 0.75 kgs at 1.25 meters. All right. So we are going to have we'll use the sum of the forces in the y. Sum of the forces in the y equals the tension minus the force of gravity equals 0 because it's not going anywhere in the y direction. So T cos 35 minus mg equals 0. And we're solving for t. So t is going to equal T equals mg divided by cos 35. And that's going to be equal to 8.97 newtons. And that was 73. Okay, 81 states, in a mail sorting facility, a 2.5 kg package slides down an inclined plane that makes an angle of 20 degrees. So theta equals 20. With respect to the horizontal, the package has an initial speed of 2 meters per second. At the top of the incline, slides a distance of 12 meters. What must the coefficient of kinetic friction between the package and the inclined plane be so that the package reaches the bottom at no speed? So BF equals 0. All right. So we're going to find the acceleration. V final squared equals V initial squared plus 2A delta X. So 0 equals 2 meters per second, quantity squared, plus 2 times A times 12 meters. All right, and so we were going to get A equals negative 0.167 meters per second squared. I'm going to pause and erase. Okay, now we'll take the force F of the incline minus force of friction equals MA. So we have mg sine theta minus mg cos theta mu k, and I think that's what we're solving for, equals ma. So the m's can go. All right, m's can go. All right, so I'm solving for this value. So g sine theta minus g cos theta divided by, oh, no, sorry, A divided by all that. Yes, okay, so yeah, that was a little bit, solving for mu k. So I'm going to switch, I'm going to switch this with that. So I'm going to go, g sine theta minus A divided by g cos theta equals mu k. And then if you do all the math and substitute the values, which you should do, you're going to find mu k is 0.382. And there are no units on the coefficient of friction. All right, very nice. That was chapter 5.